So coming to the current class objectives. So in the previous sessions we have seen some of the normal forms, friends. So like in the implementation of this normalization, okay, so these normal forms allows us so as to perform some kind of the activities. Every normalization main activity is to get the efficient design of the database. So as a part of that normalization, we are having certain normal forms actually. So from the starting of this particular session, we discussed the functional dependencies. A functional dependency is nothing but in case of any table or in case of any relation, if you want to apply, if you want to get some kind of the relationship, if you want to identify some kind of the relationship, then there should be some kind of the functional dependency. Suppose if you observe A determines B, A functionally determines B, there is some kind of functional dependency existing with respect to A and B, two attributes. And as a part of that particular convention, we observed some kind of aspects, so these particular aspects identifies how to establish a kind of the communication while working with these kind of functional dependencies, right? So as a part of that particular thing, we have seen first normal form. A relation is said to be in 1NF. It has to satisfy the rule that every attribute, okay, every attribute in that particular table should have a single valued attribute. Single valued, friends, suppose I am having attribute 1, 2, 3 like that. Each and every attribute should only register the single value. It should not contain multiple values. Okay, so we have taken one example like employee number and as well as name of the employee, skill of the employee, like that we are having. And if you are referencing the skill of the employee, that particular skill specifies that maybe he is having multiple skills, and those particular multiple skills can be observed in such a way that these particular skills we are representing in a single column, okay, which is not allowed as per the 1NF notation, because multi-valued attributes won't be allowed. Okay, that is the reason. So we need to have some alternative, like we are splitting that particular attribute into multiple records. Okay, so just one record data science and another is ML. But in case of the another thing, just we are having multiple values in a same column, which should not be happened. Okay. So that thing we have seen in the 1NF notation. And coming to the second normal form, okay, we have seen some kind of the partial dependencies. Suppose I am having some kind of information with me, and that particular data item, okay, that particular data item is identifying the notations like which is partially dependent. Suppose if you are referencing the name and course, which are non-keys, okay, and ID and email are nothing but the keys. And in this particular case, this particular course, with the help of the ID you can get. Actually K1, K2 are the composite keys, and no partial dependency should be entertained. So whatever the values we have taken, and those particular things should be avoided the partial dependency. No non-key should partially dependent on the key, part of the key. So it should be fully functionally dependent. This also we have seen. And we studied about the third normal form, friends, thereafter. So this 3NF specifies one of the important rule in the discussion of the normal forms is if I want to achieve nth normal form, I should complete the n minus 1th normal form. Suppose if I want to implement the third normal form, then I should complete the second normal form. The relation must be in the second normal form. And one of the important thing related to the third normal form is we need to identify. So we need to identify whether these particular attributes are having any transitive dependency. Transitive dependency A to B and A to C. Suppose I am having some 3 columns, friends. For observing the transitive dependency, 3 columns are required. and A to B and B to C, and if there is a possibility of observing relationship between C and A, then there is a concept of transitive dependency exists. Okay, and we should observe the removal of that particular transitive dependency, and so as to maintain that you should have the support of the referential integrity. Referential integrity playing a vital role, friends, in the observation of the transitive dependency. Those things we have seen. And next we discussed about the related thing, so which is nothing but that stronger form of the third normal form. So sometimes, friends, while working with any kind of the normal form, these particular normal forms are helpful for the sake of designing the database in the efficient manner, and most of the companies use up to the third normal form, but they may want to strengthen the corresponding normal form in the higher manner also. Then we are having the concept of the Boise-Codd normal form. Okay, Boise-Codd normal form. Let us have a look on this. Boise-Codd normal form also we have seen, like every determinant must be a candidate key. So according to that Boise-Codd normal form, there are certain combination, friends. Key can generate the non-key. A key can generate the non-key, and key can generate another key also. That is possible. But what should not be is the non-key. We should not depend on the non-key so as to generate the key, or you should not generate non-key so as to generate the candidate key or something like that. Okay. So here whatever the observation we are here seeing, and key 5 or key 6, okay, whatever the keys we are talking about, and these particular things observes that which is not a candidate key. And that's what we discussed left hand side. Suppose if you are talking about this particular relationship or this kind of the functional dependency, and if you are not knowing whether the left side is key or non-key, then there is a condition, friends. Every determinant is a candidate key. What do you mean by determinant? Determinant in the sense, suppose if you are having this like this, friends, A functionally determines B. I can say this A as determinant, okay, and B is nothing but dependent. B is nothing but dependent. Now you observe, according to the condition we need to achieve is every determinant must be a candidate key. So in that particular case, just we have seen some example and we achieved that. Okay, let me observe this thing, note, friends, like in case of the notations like 1NF, 2NF, 3NF, and now BCNF completed. Now we are into the observation of, okay, so we are into the observation of these things actually. Okay, not share, something happened, friends. Excuse me. Okay, so if you are referencing the fourth normal form, friends, actually, okay, fourth normal form, if you see, okay, now if you refer the fourth normal form, this is the advancement only, but the thing is very the definition is very simple, friends. Observe here, it should meet all the requirements of the third normal form. We know that because nth normal form, if I am talking, and if you are observing the nth normal form, the relation must also satisfy the n minus 1th normal form. Okay, for that purpose what we are trying is, whatever the fourth normal form we are discussing, first the relation must satisfy the 3NF notation. It should satisfy the third normal form. And one more important thing is, attribute of one or more rows in the table, whichever the attribute I am having, one or more rows in the table should not result in more than one rows of the same table, leading to multi-valued dependency. Observe here, friends, very simple, but you should be very cautious while defining these kind of the normal form. 1NF you can easily tell, no multi-valued dependency. 2NF, no partial dependency. 3NF, no transitive dependency. BCNF, every determinant is a candidate key. Likewise, the technical statements you can use. But there are certain observations, friends, here while working with your fourth normal form, that is attribute of one or more rows in the table. Okay, suppose course, if I am considering subject, lecturer, and as well as the books, for example, attributes, these are all the attributes of one or more rows in the table should not result. Okay, so if you are refer this particular thing, and it should not result in more than one row. Actually our discussion is, friends, in case of normal forms, or in case of any key kind of the things, every key is used. Okay, every key is used so as to observe the records without any ambiguity. The same rule is going to apply for the normal forms also, no matter whether I am using the key or whether I am using the candidate key or it is a determinant. One fundamental aspect is at the moment I am trying to access some data, it should give the without any ambiguity I should get the data. And here a small modification, friends, a small modification. What is that is, in case of the fourth normal form, if I am selecting any attribute, if that attribute is giving the multiple values related to that particular value or related to that particular data, then we need to avoid that thing. So observe here once more, I am reading attribute of one or more rows in the table. Okay, whatever the attributes we are talking about in the table should not result in more than one rows of the same table, leading to multi-value dependency. One simple example I am taking, friends. Here we are having subjects, multiple subjects we are having, okay, like mathematics, physics, and chemistry, and who are all handling those particular subjects also we are managing, and the related books also we are managing. Now friends, if you observe, if you are typing mathematics, what it is giving, maths book 1 and maths book 2. But as per your lecturer, he is taking some X lecturer is there, LX, and he is suggesting you maths book 1. Okay, so that he prepare all the content from that particular source, and he is getting you the things related to that particular subject. And another lecturer is there, suppose Y is there, another lecturer Bosco, and he is also teaching the subject, and but he is preparing subjects in mathematics book 2. Now the problem here is, friends, at the moment you are searching for mathematics subject and the corresponding books, you automatically get maths book 1 and as well as the maths book 2. Okay, so if you are referencing the kind of the problem you are observing in this particular subject notation is, at the moment you are please who are unmuting, friends, just to mute yourself, we are getting some disturbance. Please unmute all. Sorry, mute. Some kind of echo. Yeah, thank you. Thank you, friends. And if you observe the problem with this thing, friends, to understand it clearly, consider a table with subject, lecturer who teach each subject, and recommended books for each subject. Now suppose one person from our class want to get which are all the recommended books, because he don't know which are all the textbooks the lecturer following. Maybe that class he might have missed that particular class, or he is not aware of the things. So automatically he end up with two books, friends, for the mathematics, maths 1 and maths book 2. So this is the ambiguity actually. I mean, in this particular case, what is our expectation is attribute of one or more rows in the table should not result in more than one rows of the same table, leading to multi-value dependency. Okay, and now at the moment you are observing, now what we are going to observe here is, friends, subject if I am taking, suppose mathematics if I am taking, we are having two lecturers actually, Alex and as well as the Bosco. And similarly, if I am talking about the subject, we are having the books also, maths book 1 and maths book 2. Both the conditions should not be repeated. Actually, that's what we are seeing here, friends. One or more, attribute of one or more rows in the table. So now you observe here, at the moment I am talking about the subject, automatically I am ending up with two lecturers, Alex and Bosco. But whereas at the moment you are talking about the corresponding subject, again you are ending up with maths book 1 and as well as the maths book 2. Okay, and this is a multi-valued dependency on subject. Just we are dependent on this particular subject matter, and related to this particular subject, two problems are there. For the same subject we are ending up with multiple lecturers. For the same subject we are ending up with multiple books. So this is a multi-valued dependence on the subject. If we need, okay, if we need to select both lecturer and books recommended for any of the subject, it will show up lecturer multiple times, books multiple times combination, which implies lecturer who recommends which book, which is not recommended at all as per the fourth normal form, friends. We are not talking about the general aspect. That is what you should be very cautious, very clear. Up to BCNF we are very clear. Okay, now we are started with the fourth normal form. According to the fourth normal form, one simple notation is, if I am picking up any of the attribute, it should not end up with the multi-valued. And if you are considering those kind of the relationships, functional dependencies, if you are referencing the subject, okay, if you are referencing this particular subject, I can take the subject related to the lecturer. I will end up with two lecturers for the same subject. Physics, chemistry, it is okay. Only for mathematics we are having this problem, friends. And here subject and books also, a physics book and as well as the chemistry books, maybe they are some errorless physics or some whatever the books we are having. So those particular books we are getting and we are preparing. But whereas related to the maths, I am having multiple books. Okay, like multiple books if I am having, that's not a problem actually in case of general discussion. But if you want to convert your table into the fourth normal form, then this condition should not be there. Like if I am taking one subject, it should not give multiple lecturers. If I am taking one subject, it should not give the multiple books. Okay, and how do we solve that? Just have a look on this, friends. So just we are having this problem. Now you observe here, what we are doing is, we are splitting this entire table into two tables. Like one is course lecturer and course books. Actually in the earlier table we are having a single table called course with the subject, lecturer information and as well as the books information, and we faced some problem of repeating or multi-valued for the lecturer and as well as the books if I am trying to get the contents related to these aspects. Okay, now at the moment we are talking about these things. Okay, I want to split these particular tables in such a way that I want to, because we are facing the issue with this multiple lecturers and as well as the multiple books. Based on this thing, what we are doing is course lecturer and as well as the course books. Okay, and now what we are doing is subject and lecturer, a split, and as well as course book, subject and as well as the books. Now just observe here, friends. Now if you want to know the lecturer names and books recommended for any of the subject, we will fire two independent queries. In the earlier case, friends, what we are doing is, for the maths we are getting two lecturer names and as well as the two books names. Okay, so which is nothing but the multi-valued access we are doing actually. So maths, if I am taking LX and as well as I am getting two books. Maths, if I am taking maths book 1, I am getting the dependency lecturers. So as to avoid that particular convention, what we are doing is, this time what we are doing, just we are, if you want to know the lecturer names and books recommended for any of the subject, we will fire two independent queries rather than a single query. In the earlier case, if you are maintaining the subject information and as well as the lecturer information, automatically you will be getting the multiple values for the query. But our requirement is, at the moment I am selecting this particular splitting of the tables, there is no repetition. Okay, no repetition like books and as well as the lecturer for the same attribute. Rather what we are considering is, hence it is removing. Okay, so just it is removing, it removes the multi-valued dependency and confusion around the data. Because suppose we are talking about the three attributes, it's okay to manage maths book 1 and maths book 2 with x and y kind of the lecturers. But whereas if you are having some 15 columns for example in the real time scenario, and in those particular 15 columns and by selecting some project ID, and it is repeatedly giving the locations, and it is overlapping the corresponding employee names and as well as the appropriate skills, which is very difficult to identify the correctness of the data, friends. Mainly it is creating the confusion, and which creates some kind of the ambiguity. So it is always better if such kind of the dependencies are there, if such kind of the multi-valued dependencies on multiple attributes if you are having, then better you split those particular attributes by identifying where the problem is occurring. The problem occurs here with respect to the lecturer and as well as the books. So we separated those two aspects rather than considering a single row. Okay, because in the earlier case, if I am considering the single row, it is creating the combination of the data. Okay, combination of the data. So but whereas at the moment you are talking about these particular splitting of the tables, so we can split the course lecturer in one thing, and of course it is having the subject information and as well as the lecturer data, and thereafter you can observe the course books subject and as well as the books information. Okay. Hence it removes the multi-valued dependency and confusion around the data, thus the table is in the fourth normal form. Frankly speaking, friends, if you are observing the 1NF, 2NF, 3NF and as well as the BCNF, some kind of the technicalities are there, like you need to observe the functional dependency, multi-valued property, partial dependency and transitive dependency, and every determinant is a candidate key. Like that, some kind of the technical aspects surrounded by functional dependency can be observed. But whereas if you consider, at the moment you consider this fourth normal form, our intention is only to identify so any multi-valued attributes with respect to multi-valued rows are there or not. If that is the case, we need to resolve that particular ambiguity for the clarity of the data. So just you are given some kind of the table and you ask to convert that particular table into the fourth normal form. Your difficulty is, friends, up to the BCNF only, because all those particular things should be verified and some kind of the definition we have to see, and thereafter only it is possible to observe the kind of the information. But whereas at the moment you are observing this fourth normal form, it purely your sense of requirement according to the application. So just you observe the attributes and as well as the rows information, and based on that particular convention, whichever the ambiguity is there, whatever the ambiguities we are having, it is enough to resolve those particular ambiguity. So you can achieve the fourth normal form by following these kind of the conventions. And this is what, friends, how you can observe the fourth normal form. Okay. So just the fourth normal form, the important point is attribute of one or more rows. Here one or more rows, lecturer and as well as the books in the table should not result in more than one rows of the same table leading to multi-valued dependencies. Same table leading to multi-valued dependencies. So reason is, here mathematics if you are taking, it is giving Alex and Bosco in the lecturer column, and similarly for the same mathematics we are taking maths book 1 and maths book 2, which is nothing but more than one row we are getting of the same table and leading to multi-valued dependency. Yes, mathematics, it is having multi-valued dependency, and as well as this is also lecturer and as well as the books is having multi-valued dependency. Observe here, friends, it's not the multi-valued attributes, multi-valued dependency. Reason is so let me give some this example I will take. Okay, multi-valued attribute in the sense, friends, multi-valued dependency, meaning that what it says is, suppose if I am taking the appropriate record. Okay, so 1 minute, friends, it is asking system restart. 1 minute. Okay, so if you are observing the multi-valued dependency, what it says is, suppose we are considering the course maths, and it is what it is giving some lecturer 1, and at the same time it is giving lecturer 2 also. This is fine, but to this particular thing, again we are getting book 1, maths book 1 reference, and as well as book 2 reference, and there is a multi-value dependency among lecturer and as well as the book, okay, which should not happen, okay, it should not. So to resolve that particular thing, what you can perform is, so just you can take course, okay, and as well as the lecturer in one table, similarly course and book in another table. So automatically, if you are getting this particular thing, of course you can get the values. So like course, if you are selecting, multiple lecturers are there for the same course, and if you are selecting the course, you can get the multiple books. But in the previous example, like if I am taking all the course, lecturer and as well as the book in the same table, I am ending up with the query like, there is a dependency of the subject and as well as the lecturer. It is giving two values, and at the same time it is also giving multi-value dependencies. No multi-value dependencies must be there in the discussion of the fourth normal form. Okay, hope this is clear, friends. Any doubts, please let me know, because the fourth normal form main important point is no multi-value dependencies while working with any kind of the table. Okay, that particular table should not end up with the multi-value dependencies of the same table, okay, leading to reference of the two rows in multiple columns, not in the single column. Okay. And how can you split this thing? Just to wherever the problem occurs, okay, because we are facing the problem with these who are handling the subject, and which are all the subjects related to that particular thing, which are all the books related to that subject. So we split that thing related to subject and lecturer as one table, and subject and books as another table. So there is no question of linkage of lecturer and as well as the books. You can individually refer. For which subject what is the book, and which subject who is the faculty member. So like that you can achieve. It removes the multi-value dependency and confusion around the data that the table is in the fourth normal form. And the last one, friends, in the discussion of the normal forms, we are having the fifth normal form. As usual, if you refer any kind of the normal forms, these particular normal forms can be identified. Okay, if you are referencing the fifth normal form, it should be in fourth normal form. Okay, as per the analogy, nth normal form if I am having, and that n-1 normal form should be satisfied. So as per that analogy of the fifth normal form, fourth normal form, just now we have seen, it should not have the multi-value dependency. And if we can, this is bit tricky, friends, easy only, but just to observe here, very interesting. Fifth, out of all these normal forms, very simple normal form is the fifth normal form. This is what you call project join dependency, friends. Okay, project join dependency. Projection already we have seen while talking about the relational algebra, those kind of the operations. We have seen some kind of operations like projection, selection, union, like that we have seen. What do you mean by projection, friends? Projection specifies that just if I want to get some kind of the identified columns, and if I want to project some kind of the data, then I can go with the projection. Now if you refer, this kind of the fifth normal form can be known as project join normal form. Okay, so in the brief description what I am giving is, so just if you are referencing, observe here, friends. So in case of the fifth normal form, what you can observe is attribute 1, attribute 2 and as well as attribute 3 are there. Projection specifies, friends, A1, A2 if I am taking, and A2 and as well as A3 I am taking, and A1 and A3 are taking, which are nothing but the projection. At the moment I am joining all these things, okay, I should not lead to duplicates, and I should generate the original data. Very simple, friends. I should generate the original data. Okay, now you observe I am having certain attributes with me, A1, A2, A3, and for the purpose of processing the queries, I have taken only A1, A2, and after some time I want to process some kind of the query which is involving A2, A3, and we are having some A1, A3 also, like three different sets of the attributes I am having. Now at the moment you observe this, friends, and if I am projecting means selection of the corresponding attributes out of the existing n number of the attributes. I am having A1, A2, A3. I am projecting A1, A2 at one time. I am projecting A2, A3 at another time, and A1, A3 in another time. But after some time, if I am combining these particular things, I should not generate the duplicates, and I should be in a position to generate the original data without any loss. This is also known as lossless join decomposition. Very, very important, friends. Lossless join decomposition. Lossless join decomposition. Join, okay, after splitting, because we are decomposing the appropriate data in such a way that A1, A2, A3 we decompose it into A1, A2 at one moment, A2, A3 as per requirement, and A1, A3. That is the decomposition. Again we are joining the appropriate data. It means I am picking up A1, A2 from this, and A3 from the third one, and A1, A3 from the third query. Okay, A1, A2, A3 I want to pick up. Now at the moment you identify these kind of the notations, okay, if I am combining these things, that's what I should get the lossless join decomposition. Lossless means without any loss, without any disturbance, or without any loss of the data. If I could able to generate the appropriate values, okay, that is what you call the lossless join decomposition, which you can achieve with the notation of the fifth normal form. Okay, very simple notation, friends. Now we are seeing the definition. The same thing we can reframe. Observe here, if we can decompose table further to eliminate redundancy and as well as the anomaly, and when we rejoin the decomposed tables by means of the candidate keys, we should not be losing the original data, or any new record set should not arise. It means, friends, the data should not be lost. We should not miss any data, and one of the important thing is we should not generate any duplicate data or any new data which is not at all observed in the original data. Maybe sometimes, friends, so just we are working with some kind of the attributes and some kind of the queries. At the moment I am rejoining those particular tables or attributes, we may end up with some kind of duplicate records, or some kind of the new data records may be added to our final result, which should not happen. Okay, so just if you are observing this fifth normal form in a single liner, okay, suppose I am taking some table, I am splitting that particular table, again I am rejoining the table. That my requirement is whichever the data I am having, that data should be populated without any loss. One more important thing is it should not generate any new record set which is not there in the source set. Then only we can say that is the main property of the fifth normal form. This is what you call lossless join decomposition, or project join normal form. Project join normal form. Now you see here, friends, again I am reading this. If we can decompose the table further to eliminate redundancy and as well as the anomaly. Anomaly we are discussing from starting point, friends. Anomaly is something like, which is insertion anomaly, deletion anomaly, and as well as the update anomaly. The main important point why we need to select this particular normal form and the process of the normalization is to avoid these anomalies. Suppose I am having one huge table and I want to insert some record, and due to unavailability of few columns, I cannot insert the corresponding record into the table. That is the insertion anomaly, error related to the insertion. Similarly, if I want to delete something, as the entire table is a single table I am maintaining rather than maintaining the multiple tables. If I am deleting something, I am deleting the required data also. That is the deletion anomaly. Updation in the sense, friends, as we are representing the entire table in a single table, and if I am updating, unnecessary records also, unnecessary attributes also getting updated. So if you are referencing these things, mainly the decomposition. Hello,
Rio, Rio.
who is that? Mohammed? Mohammed, I am removing you. Okay, very good. So let him talk whatever he want. So if you are referencing the fifth normal form, this particular normal form allows us, we can decompose the table further to eliminate redundancy and anomaly. And when we rejoin the decomposed tables by means of the candidate keys, because some property must be there, friends, some property must be there, because just like that we cannot rejoin the tables. There are certain candidate keys or primary keys, and we should not be losing the original data. That is the basic requirement, or else any new record set should not arise. These two are the conditions, friends. The lossless, the data should not be lost, and new record set which is not identified so far should not be generated. And in simple words, joining two or more decomposed tables should not lose records nor create new records in a single liner. It should not lose the records, and it should not create the new records. Okay. So if I am observing these particular aspects, friends, the fifth normal form is also known as project join normal form, is a level of database normalization designed to reduce redundancy in relational databases, recording multi-valued facts by isolating semantically related multiple relationships. Okay, so bit additional things we are talking, friends, like our aim is to reduce the redundancy, and which are used to record multi-valued facts by isolating semantically related multiple relationships. Okay, so we are having some kind of the relationships within the table, and based on those particular conventions we should follow the lossless join decomposition. Let us have a look on the example, friends. We have taken some kind of the example with the three columns, friends, which is nothing but a traveling salesman information, and this traveling salesman is giving publicity or selling the goods related to particular brand and particular product type. Okay, if I am considering some brands, and based on that particular brands, suppose if I am taking HCL or HP kind of the brand, there are pen drives and as well as the laptops and some kind of the audio or video devices. Like that we are having many products related to a particular brand. And if you are referencing, friends, you can easily observe, if I am considering one salesperson, he is selling multiple brands actually. Okay, this Jack is selling ACME brand, and related to this particular thing, vacuum cleaner and all the other kind of the brands would be there. So, and if I am taking Jones, okay, he or she is representing some kind of the brands related to some kind of the products. Okay, this is the simple table. Now you might have observed this. Can you give which is the primary key here, friends? Can you give this any primary key? What is the primary key here? Okay, can you expect any, because primary key, which should not be repeated. Okay, anyhow null is not there. Okay, you can say no null is there, but if you are considering this one, this is repeating. If you are considering this one, this column is also repeating. If you are considering product type as primary key, this is also repeating. Then what is the primary key, by the way? What is the primary key from this table? Can any expectation? Yeah, Sandeep only, na? No, will be no. Brand, if you are taking as the primary key, it should not be repeated. Yeah, some other. Okay. Product type also repeating, na Sandeep? Product type also repeating, and Bhavana is saying no. I am asking, primary key is there. Primary key is there. Okay. So observe here. If you combine these three things, then it becomes the primary key, friends. Because up to now we have seen, if you observe this composite case, okay, and at the moment you are talking about, yeah, at the moment you are talking about this particular table, traveling salesman, brand and product type together becomes the primary key, not individually, not even two also. Because if I am considering traveling salesman and brand, he is selling the same brand with different product types. I cannot take traveling salesman and brand as the primary key, because there is a repetition. And similarly, if you are observing traveling salesman and product type, there are multiple products, friends. There are multiple products, and as well as the multiple salesperson with the same name. I cannot take this also as a primary key. So together, if you take traveling salesman, brand along with the product type, then only I can get the individual data. Observe here, first record, if you are considering jog, ACME, some kind of the product, and same product is not repeated, you can observe here. Okay, same product is not. And if you observe the entire records, if you are considering together, the entire three columns are composite primary key, that is traveling salesman, brand and as well as the product type. All these three are primary key, not single or not multiple, but three, all the three attributes, whichever the attributes I am having, all those particular three attributes are nothing but the primary keys. Now the primary key, if you am considering, the primary key is the composition of all three columns. Also note that the table is in fourth normal form, friends, since there are no multi-valued dependency and joint dependencies in the table. Okay, no column, like which by itself is not a candidate key or a super key, is a determinant for other two columns. Okay, so if I am considering these particular, let me show you this example, friends, so that you can easily relate this particular definition. Observe here, what we are doing is, we are taking product type by traveling salesman as one record, as one table, and we are taking product type and brand as another table as a combination, and we are taking traveling salesperson and as well as the brand as the another table. Now you observe here, in the earlier table, the problem is actually according to the fifth normal form composition 4NF, since there are no multi-value dependencies, in the table. No column is a determinant for the other two columns. No column means whatever the columns we are talking about is a determinant for the other two columns. Because if I am saying traveling salesperson, I cannot take this as a candidate key or a determinant. And if I am taking brand, I cannot take this as a candidate key or a determinant. And product type. So if you are referencing this thing, definitely the table is in the fourth normal form, no multi-valued dependencies. But according to our requirement, we need to split the table. How we are going to split is, only the thing is, friends, in case of the fifth normal form, our assumption is, as more number of the repetitions and redundancies are there, what we are doing is, the table is perfectly alright actually. If you observe this table, we didn't find any errors in this particular table. But what we are trying to do is, for the sake of processing the queries without involving all the three attributes, there may be a possibility of involving traveling salesman and brand, and traveling salesman and product, sometimes product type and as well as the brand. And in that particular case, unnecessarily we are repeating, suppose if I want to represent a brand along with the product type, we are repeating the traveling salesman also. And if I want to find out the traveling salesman related to the product type, unnecessarily we are repeating the brand also. And if I am getting only, if I want to get only brand and traveling salesman, unnecessarily we are repeating the product type also, which should not be required. Okay. In that case, what we are doing is, according to our requirement, there is a tie between traveling salesman and product type as a particular table, and you can see the product type and as well as the brand that you can observe, and finally the traveling salesperson and as well as the brand you can observe. And by doing so, friends, and if your query is related to any brand and product type, you can exclusively select this second table. And if your query is related to the traveling salesman and as well as the product type, you can observe, you can identify, okay, only this particular first table. And in the third table, if you are observing traveling salesperson and as well as the brand information, yes of course you can perform this kind of activities related to the brand and as well as the traveling salesperson. Okay. So this is what how you can refer the 5 normal form or 5th normal form. So whatever the data I am having, so just if you are referencing traveling salesperson and as well as brand, and if you are referencing the product type, what we are doing is initially these particular 3 together, okay, these particular 3 together observing as a composite key. Now if you are referencing this thing, friends, TSP, traveling salesperson, and brand and product type, okay, all these 3 things are composite primary key. Now what we are doing is, sometimes there is a possibility of first combination is traveling salesperson and as well as the brand information. This is first combination 1. And sometimes I want to get the traveling salesperson along with the product type he is selling, that is combination 2. Sometimes, friends, some company want to manage which are all the brands related to the product types. This is the combination 3. This is nothing but the projection, friends, actually projection. Now what we are doing is, at the moment you can combine these particular 3 notations. Anyhow, we have generated 3 different tabular representations, and again if you are combining also brand and as well as the product type, there is no chance of losing the data plus generating the new data. There is no chance, friends, because we are very with this particular convention, whatever the things we are following, and you can easily generate the appropriate information whichever the data, because our requirement is so as to split accordingly. Whichever the data I am having, I need to split this particular data according to the requirement, and whenever there is a possibility I can join this particular data without any loss. Okay. So this is what you call the lossless join decomposition, friends. Okay. So this is what how you can refer the all kind of the normal forms. So 1NF notation, in a single valued, every attribute must be a single valued, and if you are referencing the 2NF, no partial dependencies, and if you are referencing the third normal form, what do you mean by this, friends? No transitive dependency, and if I am referencing the BCNF, this is important, friends, because this is not a separate normal form, but stronger form of 3NF, And next what we are doing is, just what we are observing is, in this BCNF, okay, every determinant is a candidate key. Determinant is a candidate key. What do you mean by determinant, friends? Suppose if you are considering A functionally determines B, here A is determinant. Left side value, whatever the value we are having in the left side, you can say that as a determinant. And one of the important aspect here is, after completion of this thing, we have seen the 4th normal form. Okay, what is the 4th normal form, friends? No multi-valued dependencies. Okay, no multi-valued dependencies. Finally, the fifth normal form. What it is saying, friends? Lossless join decomposition. Lossless join decomposition, or you can say this kind of the thing as project join normal form. You can easily say that PJNF, project join normal form. So this is what, friends, how you can observe the concept of the normalizations, and according to our requirement you can perform whichever the normal forms or whichever the normalization. Okay, so if any doubts